Today, I will report on my learning journey in this machine learning course, including the knowledge I have mastered, the experiments I have completed, the challenges I have encountered, and my thoughts on my future development. Before taking this course, I had some superficial understanding of machine learning, knowing that it could be applied in fields such as image recognition and speech recognition. However, I basically had no systematic understanding of the internal mechanisms of machine learning, such as how models learn and how they are trained. Therefore, I hope to establish a complete machine learning framework through this course and master the entire process from data preprocessing to model evolution, and be well prepared for future scientific research or practical application. The theoretical part of the course enabled me to establish a basic combination. I have learned the three main types of machine learning. They are supervised learning, unsupervised learning, and reinforcement learning. I understood their respective application scenarios. For example, supervised learning is suitable for handling label data and is often used in classification and regression problems. Unsupervised learning is, is applicable when the data is unlabeled, such as cluster analysis. And I also learned various model evolution metrics, including accuracy rate, recall rate, precision rate, F1 value, and so on. They are all important reference for measuring model performance in actual project. The first experiment was to implement the perceptual model using Python to solve the classification problem of Boolean logical functions such as and, or, and not. By adjusting the learning rate and weight, I observed the error changes during the training process, which helped me understand the working principle of the perceptron. The second experiment was about cluster analysis. I used the k-mean and hierarchical clustering models to cluster datasets with complex shape. I, I have also learned how to analyze the clustering efforts through graphical tools and compare the performance difference of different algorithms. In the third experiment, I constructed the ResNet 18 deep neural network using the PyTorch framework for the task of cat and dog image classification. And during this process, I not only learned the data preprocessing, model building, and training procedures, but also attempted to introduce SE block attention mechanism to optimize the model performance. And I also learned the methods of adjusting hyperparameters such as the learning rate, batch size, and the number of training runs. Throughout the entire process, I also encountered many challenges. For example, when I first came into contact with PyTorch, I was not familiar with the implementation methods of the network structure. And at the beginning, the model is prone to overfitting and performance poorly on the validation set. However, by reading documents and communicating with classmates, I gradually learned how to use the validation set for parameter tuning, how to solve overfitting, and at the same time improved my ability and debug and solve problems. Apart from the technical aspect, I also realized that machine learning involves ethical considerations as well, such as issues like data bias and algorithm transparency. If not pay attention to them, it may lead to unfair results in AI. This is also the valuable understanding I have gained in this course. Thanks to Dr. Aida and classmates for their mutual help. It enabled me to systematically understand and learn machine learning within just a few months, and I will continue to study the field of artificial intelligence and apply the knowledge I have learned to my report.